We know the average temperature of Earth is about 15 degrees Celsius. But have you ever thought about what the temperature on Earth will be if there is no atmosphere at all? Or like, what if there is atmosphere but without any greenhouse gases? So in this video, we are gonna discuss about it and get some proper numbers. To begin with, let us consider Earth as a black body. In that case, the power absorbed will be equal to the total power emitted. To begin with, we need to calculate the power absorbed. Obviously, sun is our source of energy. Let this yellow circle be sun and this blue circle be earth and the radius of the earth be RE. Let them be at a distance of d, which is equivalent to 1 astronomical unit, that is 1.496 into 10 raised to 11 meters. The total amount of energy emitted per unit time by sun is luminosity. It is uniform in all directions. So what is the total energy per unit time per unit area that is reaching the earth? For this, we can consider sun to be at the center of a sphere of radius capital D. Obviously, then the earth will be on the surface of this sphere. So the total energy per unit area per unit time through this sphere will be what? Total amount of energy that is reaching earth per unit area per unit time. So L by 4 pi d square will give this value. Now this is the energy that is reaching on unit area. So what is the total energy that is received on earth? Also the thing is like not total earth surface is exposed to sunlight. So we are considering a circular disk of radius same as that of the earth's radius, that is Ra in front of the earth. So total amount of energy that is passing through this will be what reaching the earth. So if we multiply earlier L by 4 pi d square with the area of this disk, we will get the necessary value, that is L by 4 pi d square into pi Re square, and the value of L is 3.828 into 10 raised to 26 watts. It's not finished yet because not all energy that is receiving on earth is absorbed by earth. Some are reflected back. So albedo is the measure of this reflection, that is albedo is the ratio of total radiation reflected to total incident radiation. So if we take 1 minus albedo, that is 1 minus A, we will get the ratio of radiation that is absorbed. So if we multiply our earlier quantity with 1 minus A, we will get the total power absorbed. Now to find the power emitted. According to Stefan's law for Blackbody, the power emitted per unit area is sigma T raised to 4, where sigma have the value of 5.67 into 10 raised to minus 8 watt meter raised to minus 2 Kelvin raised to minus 4. So the total power emitted will be sigma T raised to 4 into surface area of our earth, that is 4 pi Ra square. Let the earlier equation be equation number 1 and this be equation number 2. Now we can equate the power absorbed to power emitted, that is 1 equivalent to 2. L by 4 pi d square into pi Ra square into 1 minus A equal to sigma T raised to 4 into 4 pi Ra square. We can cancel out pi Ra square on both sides and write the equation for T raised to 4, and from there we can get the expression for T as L into 1 minus A divided by 16 pi d square sigma whole raised to 1 by 4. This is the expression for finding the temperature. So coming into our cases, like without atmosphere there won't be any clouds to reflect the radiation back, even though there will be some reflection done by the earth's surface. So the albedo can be approximated to 0.1 theoretically, and if we substitute the values in the equation, we can get the value of temperature as 271.097 Kelvin, that is approximately minus 2.05 degrees Celsius. Very cold now. Now coming to our second case with atmosphere but without any greenhouse gases. In that case there is atmosphere and there is clouds. So the albedo is 0.3 itself. Because with or without greenhouse gases, albedo is not changing much because greenhouse gases are not directly involved in changing any albedo. So if we calculate the temperature by substituting the value of 0.3, we will get 254.59 Kelvin, that is approximately minus 18.56 degrees Celsius. We can see that the actual temperature on Earth with greenhouse gases is about 15 degrees Celsius, and without greenhouse gases we got it as minus 18.56 degrees Celsius. So there is a temperature difference of approximately 30 degrees Celsius here. This marks the inevitability of having greenhouse gases. So we can see that the greenhouse gases are kind of having an effect like Earth with a blanket to keep it warm. Actually, what greenhouse gases are doing in our atmosphere is like it is completely transparent to the short wave incoming solar radiation, but the long wave terrestrial radiation emitted from the Earth are reflected back by them to Earth itself. In that way, they are kind of heating the Earth again. But to calculate the value of temperature on an atmosphere with greenhouse gases, we need to consider some advanced models. We need to consider the radiation absorbed and emitted by the atmosphere, and we need to consider the scatterings in an atmosphere and also the clouds, obviously. For those, we need some advanced model. As of now, we have calculated the value of temperature on Earth without atmosphere and with atmosphere but without greenhouse gases. For seeing calculations using more advanced atmospheric models, stay tuned to this channel. Thank you.